All right, if you're an engineer and you're trying to actually get your head around AI, you're in the right place. We're going to skip all the hype and get straight to the lessons learned in the trenches. This isn't about finding some magic shortcut. This is a real, boots-on-the-ground reality check on what it takes to build with this stuff. And let's just get this out of the way right now. This is not some shiny success story about becoming an AI wizard overnight. Far from it. This is a frank look at the struggle, the misunderstandings, and the fundamental mindset shift you have to go through to get from being a casual user to a real operator.
I bet this looks familiar to a lot of you. It definitely does to me. We all started here, right? Using these new tools for our day-to-day tasks, thinking, hey, I'm getting pretty good at this. I'm a power user. You know, rewriting emails, sketching out presentations, whipping up diagrams, and it feels amazing. It's a huge productivity boost. But, and this is a huge but, there's a trap hiding in plain sight.
And here's the trap. We start to mistake being good with the tool for actually understanding the system underneath. What we're doing here is using really advanced productivity software. It's not a deep understanding of AI, it's just getting good at using a new kind of word processor.
So why does this matter? Well, it matters a ton. Believing you get AI because you can write a good prompt is a seriously flawed mental model. And it's a model that completely shatters the very first time you try to build something that needs to be reliable, predictable, and mission-critical.
The real learning, well, it usually kicks off with a moment of pain. For me, it was that jump from just being a casual power user to trying to build an actual working system to solve a real business problem. I went in thinking, yeah, I know how this works, and the result, I ran headfirst into a brick wall of failure, over and over and over again.
And that's it. That's the pivot point. That failure forces you to have a total mindset shift. You have to stop chasing clever prompts and word tricks, and you start putting your engineer hat back on. You start treating this thing like what it is, a complex system that demands structure, discipline, and actual engineering.
You know, one of the biggest hurdles, honestly, is the language we all use, the hype language. We say the AI thinks, that it reasons or understands. But an operator, someone who actually has to make this stuff work, knows the reality is much more mechanical. It predicts, it recognizes patterns, and it deals in probabilities. Getting the language right isn't just being picky, it's fundamental to building things that don't fall apart.
So, if it doesn't think, what the heck is it? You need to burn this definition into your brain. It is a stateless, probabilistic pattern engine. Stateless means it has the memory of a goldfish. It has no idea what you just talked about unless you hand it the context every single time. Probabilistic means its output is always its best guess, never a certainty. And pattern engine means it's just a ridiculously powerful parrot, matching patterns from its training data. That is the whole game.
Let's make this even more blunt. How many things does an AI actually know? The answer is a big fat zero. Nada. Zilch. That feeling of intelligence you get from it, that coherence, it comes entirely from its incredible ability to predict the next most likely word. If you miss that distinction, everything you build, your architecture, your expectations, it's all built on sand. Okay, so if we accept that we're dealing with this weird probabilistic machine and not some thinking entity, how should that change the way we work with it? What really separates someone who's just using it from someone who's truly operating it?
And man, the difference is night and day. A shallow user is tool-centric. They're always chasing that perfect prompt and they just blindly trust the output. An operator, they're thinking about the whole system. They define the constraints first. They evaluate everything before they trust anything. They're aware that models drift. They build governed workflows. And here's the biggest one. They retain full accountability. Responsibility is never ever handed off to the tool. The buck always stops with the human operator.
This is so critical, especially for those of us coming from traditional software engineering. Usually, our systems fail in an obvious way, right? It works or it's broken. It's binary. AI systems, they're not like that. They don't just break, they degrade. Their performance quietly drifts over time. The failure is this slow, probabilistic poison, which makes it incredibly easy to miss until real damage has been done.
And that leads to this powerful insight. AI does not provide discipline. It is an amplifier. It just magnifies whatever you bring to it. If you approach it with weak structure, with chaos, you will find that AI scales your failures with terrifying speed. But if you bring strong, disciplined engineering to the table, it will amplify your success like nothing else you've ever worked with.
So what does it take to become a real operator? It's not about being the smartest person in the room or knowing some secret prompts. It really boils down to 4 things: curiosity,
a real desire to know how the system actually works. Depth, the commitment to go beyond the surface. Discipline, to apply real engineering rigor. And finally, taking full, uncompromising responsibility for the outcomes.
Look, at the end of the day, this is the most important thing to remember. We have to reframe our entire relationship with this technology. AI is not here to do your thinking for you. It is here to amplify you. And the quality of what it amplifies, your expertise, your rigor, or your sloppiness and your biases, that is 100% on you.
So what's your job now? What you do tomorrow? If you're waiting for a training course or for your boss to figure this out, you're already behind. Your job is simple, but it is not easy. Number 1, immerse yourself. Get your hands dirty. Direct interaction, trial and error. Number 2, fail. A lot. You have to accept failure as the price of admission for real learning. And finally, number 3, through that process of immersion and failure, you learn how the system truly behaves, not how the hype says it should, but how it actually does. That's it. That's the job now.